It's one of the few molecules regularly named in daily headlines, lead stories, and public conversation.
Plants emit some 2.1 billion tons of carbon dioxide a year.
Regulated vehicles, carbon dioxide emissions will be reduced by 900%.
Biggest producer of carbon dioxide.
Carbon dioxide, the higher
for chemicals like carbon dioxide.
Leading cause of global warming.
What's behind the headlines on carbon dioxide? Here's the inside story. Really inside, down to the molecular level, as you'll see. To start, carbon dioxide, or CO2, is a gas, colorless, invisible at standard pressure and temperature. Under high pressure, CO2 can be compressed into a solid, known as dry ice, or dissolved in water, a process called carbonation. It's CO2 gas bubbles that put the pop in pop, or soda, depending on what part of the country you're from. And being a gas can make you burp. You can also see CO2, or at least its effects, when you make bread. Yeast eats the starch in the flour and expels carbon dioxide gas. CO2 gas expands when warm and makes the dough rise, the way helium gas expands a balloon. That's not the way most people relate carbon dioxide to warmth and warming. This is. The relationship of complex fluctuations in global temperatures, ice cover, and sea levels to this remarkably simple common molecule made of only 3 atoms. One atom of carbon, the C part of CO2, attached or bonded to 2 atoms of oxygen, the O2 part of CO2, in a linear structure. Great opportunity here to explain one of the fundamental rules in organic chemistry, the octet rule, or rule of 8. A rule worth knowing because it applies to most elements in the periodic table, including the most common, carbon, nitrogen, and oxygen. Okay, hit refresh here. Atoms have a center, a nucleus, and a certain number of electrons that orbit the nucleus in shells. Molecules are formed when atoms combine. Atoms of most elements tend to combine, so they each have 8 electrons in their outermost shell. Carbon dioxide is a great example. A carbon atom has 4 electrons in its outer shell. It needs to connect with 4 more electrons to get the magic 8. An oxygen atom has 6 electrons in its outer shell. It needs to connect to 2 more to get to 8. What happens is a little like the card game Go Fish, atomic version. The atoms align in specific ways to trade or share electrons so they can get the electron sets of 8 they need. 2 oxygen atoms connect to opposite sides of 1 carbon atom, which gives each the 2 electrons it needs to make 8. See? The carbon atom in the middle gets 2 electrons from the oxygen atom on one side and 2 from the one on the other, for a total of 8 in its outer or valence shell. Sharing of pairs of electrons is called covalent bonding. Now, back to the bigger picture, CO2 in our air and atmosphere, and in fact throughout deep space, in ice form, part of the makeup of planets. NASA rovers found CO2 ice caps on Mars. Earth's surface is much warmer than space, so most of the CO2 on Earth is present as an atmospheric gas. Carbon dioxide makes up less than half of 1% of the air we breathe. Air is mostly nitrogen and oxygen. Eruptions of volcanoes, like the one in Iceland, add CO2 to the atmosphere. And of course, so does the carbon or life cycle. Plants take in CO2, along with sunlight and water, and give out oxygen. Animals and humans take in oxygen and give out CO2. And then there's this, the burning of fossil fuels in power plants, automobiles, and factories. Oil, gasoline, coal, carbon-based fuels. In fact, the word carbon comes from the Latin word for coal. As more of these fuels and organic matter like wood and crop stalks are burned by the planet's growing population and industry, all this additional carbon does exactly what you've just seen. It bonds with oxygen in the air. Air is 20% oxygen, and makes, yes, more carbon dioxide. Where does it all go? An estimated 57% of this cook-fire tailpipe smokestack carbon dioxide is cycled into the oceans, covering 70% of the Earth's surface. Plants eat up some, most of the rest goes into the air. In the oceans and the air, more CO2 is causing serious problems. In the oceans? Well, quick rewind to making carbonated drinks. Remember, by dissolving CO2 into H2O, that, logically enough, makes H2CO3, also known as carbonic acid, a weak acid, although strong enough to remove rust from chrome. Okay, fast forward again. More CO2 in seawater, more carbonic acid, more acidification of the oceans. And in the air, buildup of CO2 and other so-called greenhouse gases in the atmosphere acts like a marathoner's thin post-race blanket, holding essential body heat close to Earth's skin, keeping the average surface temperature at about 59 degrees. Without this trap, the warmth from the sun would escape back into space, and average temperature on Earth would be just below 1 degree Fahrenheit. But adding too many layers of CO2 can have the opposite effect, trap too much heat, enough to melt ice caps, raise ocean levels, raise ocean and air temperatures, contribute to global warming. There's much more to know about CO2 and carbon credits, carbon footprints, and carbon capture. Maybe think of this video as carbon capture of another kind.